Welcome to Chemistry with Dr. Z. In this video, I'm going to explain what is Le Chatelier principle. So, Le Chatelier principle describes what happens to a system when it's at equilibrium and when something happens that tries to take it away from the equilibrium. So according to Le Chatelier principle, if a system is at equilibrium and a change is made to any of the conditions, then the system will respond to counteract that change. So what are these changes that can affect the equilibrium of the system? The first factor that can affect the equilibrium is the concentration. So if the concentration changes, then the equilibrium will also change. So let's have a look at this reversible reaction. We have two reactants, A and B, which react together to give you two products, C and D. According to Le Chatelier, if the concentration of one of the reactants or products is changed, the system is no longer at equilibrium, because at equilibrium, the concentration of the reactant and product should have like a fixed proportion or a fixed ratio. So if we change the concentration of one of the reactants or one of the products, then that means that the system is no longer at equilibrium because now the ratio has changed. The system will respond by trying to re-establish or reinstate the original concentration ratios at equilibrium. So how will the system respond? So let's have a look if we try to increase the concentration of one of the reactants, which is reactant A. So if we change the concentration or increase the concentration of reactant A, then the system will respond trying to re-establish the ratio. So try to decrease the concentration of reactants and increase the concentration of products, which mean the forward reaction will then prevail, or the forward it will push the reaction toward the forward reaction until the equilibrium is reinstated, or until we get back to the equilibrium with the same ratio of concentrations of reactant and products. On the other hand, if we increase the concentration of one of the products like C or D, for example, then again the system will respond in the same way. Now we increase the concentration of the product, the system will respond by trying to decrease the concentration of products and increase the concentration of the reactants. So reactants concentration increase, products concentration will decrease. And the only way to do this is to push the reaction toward the reverse reaction, making more reactants. So now the reaction will be pushed towards the reverse reaction, not the forward reaction. The second factor that can affect the rate of the reaction is the temperature. So any reaction should be either exothermic or endothermic. So all reactions are either exothermic or endothermic reactions. And for reversible reactions, we have two reactions going in opposite directions like here. So if the forward reaction is an exothermic reaction, then that means that the reverse reaction must be an endothermic reaction. So exothermic reaction, we know that exothermic reaction means that there will be release of energy or release of heat, which means that will be an increase in temperature in that direction. So if the forward reaction is exothermic, that means there will be increase in temperature in the forward reaction. And for endothermic reaction, which is the reverse reaction in our example, that when the endothermic reaction takes place, then that means there will be a decrease in temperature and the reverse side. So what happens if we try to increase or decrease the temperature of the system? How will the system respond? According to Le Chatelier, if the temperature is increased, then the equilibrium will move toward in the direction to try to decrease the heat because the temperature has increased and the system must be at equilibrium, which means that the system will move towards the endothermic reaction. So the direction of the reversible reaction now will be towards the endothermic reaction, which is the reverse reaction in our example. And if the temperature is decreased, then the equilibrium will move in the direction to try to produce more heat, which means toward the exothermic reaction in order to counteract the effect. So let's look at the overall effect on an exothermic forward reaction. So if we increase the temperature, there will be an increase of the reverse endothermic reaction, which means we're going to have more reactants and less products, so the overall yield of the reaction will be reduced. And if the temperature decreases, that means that the system will respond by increasing the rate of the forward exothermic reaction in order to counteract this effect, which is the decrease in temperature. So the system will push towards increasing the temperature, and then that means we're going to have more products and we're going to have more yield. The last factor that can affect the position of the equilibrium for a reversible reaction is the pressure. So when we talk about pressure, then we are talking about gaseous system because pressure only applies for gaseous systems. It doesn't apply for solutions. So what do we mean by changing the pressure of the system? Since changing pressure of the system, gaseous system, means either one of two things. Increase in pressure could mean that we have the same number of particles occupying a smaller space, or it could mean a bigger number of particles occupying the same space. So it's either larger number of particles or in a larger number of particles in the same space, or same number of particles in a smaller space. So what happens, according to Le Chatelier, if we try to change the pressure of a gaseous system? So an increase in pressure will favor the reaction that will produce the least number of molecules. When the system produces the least number of molecules or less number of molecules, that means it tries to reduce the pressure. So an increase in pressure, the equilibrium will shift to the side of the equation with the fewer number of moles of gas. So let's have an example to see what does this mean. So this is a gaseous reaction between nitrogen and hydrogen to give ammonia. This is the Haber process. And all of these species are gaseous because nitrogen, hydrogen, and ammonia are gases. The reverse reaction or the reactants, as you can see, we have one molecule of nitrogen and three molecules of hydrogen. So the overall number or the total number of molecules on the left-hand side here is 4. On the right-hand side, which is the product side, then we have only two molecules of ammonia. So on the left-hand side, we have 4. On the right-hand side, we only have 2 molecules. Now let's look what's going to happen according to Le Chatelier principle if we try to increase or decrease the pressure. So if you increase the pressure, the equilibrium will move to the right. The main reason for that is that because on the right we have less number of molecules, which means if the system is shifted toward the right, then the pressure will try to decrease. And that means we're going to have more of the product, so more toward the forward reaction. On the other hand, if the pressure is decreased, the system also needs to respond to counteract that because we need to have a balanced pressure at equilibrium or a certain pressure at equilibrium. So if we pressure is decreased, then the equilibrium will shift to the side of the equation that has the larger number of molecules, which is basically the left-hand side, which is the side for the reactant. So now the reaction will be shifted toward the reverse reaction, or the equilibrium will be shifted toward the reverse, and then that means we're going to have less product and more reactant, so we're going to have less yield of our product.